Alright, so for today's class, guys, what I'm going to do is talk through the problem that we were given for homework over the weekend. A number of people were in touch over the weekend to say that they found it kind of difficult. So, what I thought we might do today is I'll go through this one in this video. People who need the video can watch it back and see how to do it. But I'm going to give you a similar challenge now to complete during this class and upload before the end of the class, and that will be graded instead of the weekend homework. So it's to give everybody a fair chance at having a look at this, because maybe you needed to revise your quadratics. So take a look at this video, watch it back if you need it. If not, work away on the question that I've uploaded now. So in this scenario, it says a plot consists of a rectangular garden measuring 8 metres by 10 metres, surrounded by a path of constant width as shown in the diagram. The total area of the plot, the garden and path, is 143 metres squared. So the entire thing is 143 metres squared. What I could see for myself from here is that the lawn part, or the grass part, or the garden part, whatever you want to call it, you can tell what that is straight away. It's 8 by 10. So I know that that area there is going to be 80 metres squared, meaning that the path part itself would be 80 metres from the 143. So I could actually figure out what's the pink area here. So I can work that out if I wanted to. I don't know if we need it yet. I'm just writing down what I know as part of my problem solving process. So I know that that pink area there is going to be 143 minus my 80. So what does that give me in my calculator here? So 143 minus the 80 is going to give me 63. So that's 63 metres squared. And what we have then is that that's 63 metres squared. 3 students, Kevin, Elaine and Tony, have been given the problem of finding the width of the path. So they want to know what's this width out here basically. So we know what the area is, but we want the width. Each of them is using a different method, but all of them are using x to represent the width of the path. Kevin divides the path into 8 pieces. He writes down the area of each piece in terms of x, and then he forms an equation by setting the area of the path plus the area of the garden equal to the total area of the plot. So write in terms of x the area of each section into the diagram. Right, so let's do that part first. They want us to represent each part in terms of x. So if the width of the path is x, that distance there is x, and look, this distance here is x. So the area here is actually x squared. The area here is x by 8, so that's 8x. This here is x squared, and so is all of the other corner pieces. Symmetry would tell us that this must be 8x down here. This part is a width of x multiplied by 10, so it must be 10x. And then this part is x, and this part is 10, so again, we've got 10x. So they say write in terms of x the area of each section of into Kevin's diagram below. We've now done that. Okay, you can also put in that this is 80 if you wanted. Now write down and simplify the equation that Kevin should get. Give your answer in this form. Now that form you should recognise as a quadratic straight away. So remember, the area is going to be the total area, so we're going to have x squared plus 8x. So as I read across here, so plus another x squared, plus I'm going to go down now, 10x. I'm going to go down to the corner, x squared, read across, I get 8x plus x squared plus 10x plus x squared again, and then I'm going to say plus 80 because we are talking about the full area of the path here. So that's going to be important. Now they say to simplify. Now simplify means identify the like terms. So I'm going to highlight all of my x squareds. So there's an x squared, there's an x squared, and there's an x squared. So I should have 1, 2, 3, 4. I've counted 1, 2, 3, 4, 5. That's because I accidentally counted this one twice because we started there. So I'm going to remove that. Okay, so it's just that. So we have 5x squared, or 4x squareds, apologies. The fifth one, it was miscounted. So we've got 4x squareds. and then it's going to be add my x's together. So I'm going to need to identify all of the x values here now. So if I do that, I'm going to have 8x and 10x, that's 16, 8x and 10x is 18x, plus another 8x is 26x, so 36x, and you can confirm that. So 8 plus 10 plus 8 plus 10, and we get 36x is what we have there. And of course I have the 80, which gives me the total area of the entire thing, and that's going to be equal to 143. Now they want the formula in the form ax squared plus bx plus c is equal to 0. So what I'm going to do is I'm going to make this side be 0, and to do that I'm going to have to subtract 143 from both sides. So if I subtract 143 from this side, it becomes 0, and if I subtract it from here, I've got 80 minus 143, which gives me minus 63. So I've got this set up now. So 4x squared plus 36 minus 63 is what we have. And that's equal to 0. So that's our equation there, which they were looking for. Now, it says the next one. Elaine writes down the length and width of the plot in terms of x. She multiplies these and sets the answer equal to the total area of the plot. Write in terms of x the length and the width of the plot in the space on Elaine's diagram. So if we look at Elaine's diagram, we know that this is 10 here, and we know that's an extra x here, and an extra x here. So I've got x and 10 and x. That could be written as 10 plus 2 x's. So x, 10 and x becomes 10 plus 2x. If we look at the width, you've got an x plus an 8 plus an x. So we've got 8 plus 2x. Now, the whole thing then, the width of the whole thing and the length of the whole thing is what we have. We can find the area using that formula, because the area is equal to the length times the width. So the length we know is 10 plus 2x, and the width is 8 plus 2x. And we multiply those together then. So I'm going to get 10 by 8 is 80, 10 by 2 is 20x, 2x by 8x is going to give me 16x, and then I'm going to have 4x squared here again. Now, they say that she lets that equal to the total area of the plot as well. So she lets that equal to 143 as well. Now, what I need to do here is simplify, and also when I simplify, I'm going to make sure that it goes with the highest power first, meaning I always write it with the x squared at the start, then all of the x's. Now that means tidying those up together, so I get 36x plus 80 is equal to 143. And again here what we need to do is take away this from both sides because they wanted it equal to 0, and I'm going to get the exact same equation as I did before. So just another way of finding the same information. So that's our equation here. Then it says solve an equation to find the width of the path. Now both of the equations were exactly the same, and this is what I have when I looked at them. Now this is going to be a quadratic, right? So whenever we have something squared plus something x plus something else, or in this case minus something else, we're dealing with the quadratic. And what we need to think about then is either using the minus b formula or working out the factors. Now, the factors here are going to be, and it might just take a little bit of practice, you might be fuzzy on it. So what you need to revise if you're not sure at this stage is quadratics. Okay, now for me, when I do that out on paper, I get them to break down to be 2x minus 3, 2x plus 21. And you can do your check, out multiplied by out, and in multiplied by in, and it should add up to plus 36x. This then tells me that I have an equation with two things multiplied together to give me 0. The only way I could multiply two things and get 0 is if one of those things or both of those things are equal to 0. So what I'm going to write is 2x minus 3 is equal to 0, or 2x plus 21 is equal to 0. So that's what I need to consider here. 2x minus 3 is 0, or 2x plus 21 is 0. I solve this then, and I get 2x is equal to 3. So x is equal to 3 over 2. Or I'm going to get 2x is equal to minus 21. So x is equal to minus 21 over 2. Now x cannot equal to minus 21 over 2 because we can't have a negative value when it comes to width, right? X represents the width of the path. We cannot have a negative value, so you must put a line through that and say x cannot equal minus 21 over 2. That's so important here. Now, the final part says that Tony does not answer the problem by solving an equation. Instead, he does it by trying out different values for x. Show some calculations that Tony might have used to solve the problem. So what Tony might have done is he might have said, okay, I have 4x plus 36x minus 63 is equal to 0. What Tony might have done is said, okay, I'm going to say in this first place, what if x was equal to 1? So I would do 4 by 1 squared plus 36 by 1 minus 63 is equal to 0. And we'll see, okay, does that equal to 0? And he would see, okay, 4 by 1 squared is 4 plus 36 minus 63, and he gets minus 23. So that does not equal to 0. So Tony would then decide, okay, right, x is equal to 1 didn't work. What about x is equal to 2? And he would do the same thing. 4 by 2 squared plus 36 by 2 minus 63 is equal to 0. And he would see then 4 by 2 squared plus 36 by 2 minus 63. That number was 25. Now 25 does not equal to 0. So he went from being below 0 before to now being too high above 0. So what he could see is that somewhere in between those two values, so between the 1, so between 1 and 2 is the answer. Just think about that. He was too far below 0 the first time, too far above 0 the second time, so his answer must have been in between in that scenario. The next and final part then was, which of the three models do you think is best, and give a reason for your answer. So that's up to you, but Elaine's model would be preferable here, and all three models are correct, but Elaine's method was the quickest for us and the simplest for us, right? So if you go back and look at Elaine's model, we didn't have to calculate all of these individual areas. We had to calculate the area of just the width, the dimensions of the width and the length, and we were able to multiply out, and we did it in much fewer steps than what we had to do here. Additionally, when she found her values in calculating the value for x, she didn't have to trial and error a load of values, because at this stage he might get lucky, Tony might get lucky and pick 1.5, or he might be really unlucky and start with 1.1, 1.2, 1.3 and so on. So Elaine's method would be the best method here.